because I noticed that actually we are done with all the topics. So I'm just going to go through integration again because you only watch the recordings. So today I'm going to do examples and then you're more than welcome to ask questions based on the examples that I'll be giving you. So as we all know that integration only works when you have a base and an exponent the same way as your derivative. So integration is the reverse of a derivative. So when we integrate a function x to the power of n with respect to x is going to be equals to x to the power of n plus 1 over n plus 1, then we say plus c. So we have an example here. It says integrate each of the following. So we are going to start with a. So we have a function there, which is x plus x to the power of 3 is equals to x to the power of 3, 5. Then now we have to integrate. I said that when you integrate, you are going to have x to the power of n plus 1 over n plus 1. So here, because there's no exponent, it means that the exponent is 1. So this will be x to the power of 1 plus 1, and then over 1 plus 1. So I'm just going to do this on the sum, and then the rest I'll just be adding. And this will be plus. So the sum, and then the rest I'll just be adding. Please mute your mic. And then this will be plus x to the power of then 3 plus 1. Then it means it's over 3 plus 1. So I'm just going to do this for the sum, and then the rest I'll just be adding. And then also 3 plus 1. And then this is plus x to the power of 3, 5 plus 1. So we always add 1. And then when we derive, we minus 1. So this is 3, 5 plus 1 over 3, 5 plus 1. Over 3, 5 plus 1. And then we say plus c. So this will be plus c. And then it means we are going to have x to the power of 2 because 1 plus 1 is 2. And then over 2. And then this will be plus 3 plus 1. Please mute your mic. 3 plus 1, it's 4. So this will be x to the power of 4. And then over 4. And then plus 3, 5 plus 1 is going to be 4, 5. So this will be x to the power of 4, 5 over 4, 5. Over 4, 5. And then this is plus c. So this is how we derive. Do we all understand? A, please, if you ask a question based on A. Are we all fine with A? Okay. And now we move on to C. Sorry, B, not C. Okay. Now we move on to B. We have the function 5x minus 3x squared. So we have to integrate. So this will be 5x to the power of 1 plus 1, which is 2. Remember, there's a 1 here. So it means this will be, remember I said that I'm not going to repeat this step because it's too long, this one. I said I'm not going to repeat it because it's too long. Let me just delete the space. I'm not going to repeat this step that I did here. So we're just going to add. So this will be, it's 5, then x to the power of 1 plus 1, which is 2. and then it means it's over 2, and then minus, minus, and then this will be 3, and then x to the power of 2 plus 1, it's 3. So this will be 3, then over the same 3, and then we just say plus c. And then if I solve further, 3 and 3, they cancel, so I will have 5 over 2, then it's x to the power of 2. Whether you write the x to the power of 2 on the side or just next to 5, it's correct, as long as it's not under. And then we have minus, then this will be x to the power of 3, because 3 divided by 3 is 1. So you're just going to have 3, and then this will be plus c. So this is how we integrate. So we always add 1 as compared to a derivative where we minus the 1. And then we move on to c. So now c, we have this. So we can integrate when it looks like this. So we are going to solve first. Please mute your mic. We are going to solve first this function, which is 2x to the power of 3, then a bracket of 1 plus 1 over 2x to the power of 3. Relinde, I see your hand is up.
Hi, ma'am. Sorry to take you back to number B.
Okay.
When the 2 from the one that you have divided 5x to the power of 2, you say divide by 2. Where's the other 2 coming from?
It's this 2. You see, I wrote it in red. That's the same 2. I think I must
Oh.
also do it for this one. Yes. So every time when you integrate, you say n plus 2 over n plus 2. So these 2, it's 1, this 1, plus 1. Remember, we always add 1.
Yes.
Yes.
Oh, okay.
So,
Thank you.
yeah. Okay. Let me just write this one in red so that you can see. Yeah. Okay. And then now we move on to this one. So for me to integrate this, it must look like one function like this. It must not be a number outside the bracket and the bracket. So I'm going to first start by solving this part. So I am going to have, so the integral, then now I multiply. So I'm distributing this times this, then I'm going to say this times that. So when I multiply, I am going to have 1 times, so 2x to the power of 3 times 1, it's the same thing, it's 2x to the power of 3. And then plus, plus. And then now, when you multiply, let me just write it on the side first so that you can understand. So when you say 2x to the power of 3, you multiply it with 1 over 2x to the power of 3. When you multiply, this is always over 1. When we do fractions, we know that this is always over 1. So we multiply, we say 3x to the power of 2x to the power of 3 times 1. My answer is 2x to the power of 3. And then over, when I say this 1 times 2x to the power of 3, I still get 2x to the power of 3. And then my answer is going to be a number divided by itself. 2 divided by 2 is 1, x to the power of 3 divided by x to the power of 3 is 1. And number divided by itself, it's 1. So my answer is going to be 1. So this is how we get the answer. I am distributing, so I just want to show you how I got the 1 in case you ask. So I multiplied this times 1, I get 2x to the power of 3. And then I'm going to say this times that, I'm going to get my answer is going to be 1. And then now my function looks more like this. It's a function like this. So I have 2x to the power of 3 plus 1. I solved this. And then now I can integrate. When I integrate, I am going to say, we take this 2x to the power of 3. So let me do it the longest way again so that you get it. So this will be 2x to the power of 3 plus 1. You always add 1 when you integrate. Plus 1. Then this is over 3 plus 1. So this will be over 3 plus 1. And then I say plus. Baba, your hand is up. Are you correcting me? Okay. And then now we go to this 1. So this will be 1, then x to the power of 0 plus 1. If you remember from the notes, from the recordings that I did, with the constant, this is what happens. You introduce the x because x to the power of 0 is 1. It does nothing to this one. So we introduce x to the power of 0, then you say plus 1. Every time you have a constant and there's no number, when you integrate, this is what's going to happen. And then this will be over. This will be over 0 plus 1. So this will be over 0 plus 1. And then don't forget the plus c. And then now we are going to have 2, sorry. We are going to have 2x to the power of 3 plus 1 is 4. So this will be to the power of 4 over the same 4. And then this is plus. And then this is, I'm just going to write 1 for now. So this is 1. Then x to the power of 0 plus 1 is 1. So it's just going to be x to the power of 1. And then over 1, which one? The same exponent 1. So it's over 1. Okay. All right. And then this is plus c. And then we know that now we divide numbers. 2 divided by 4 is going to be 1 over 2. If you take your calculator, you see 2 over 4 is 1. 1 over 2. 2 over 4 is the same as 1 over 2. I'm just going to do it here on the side again so that you understand. So it means here I am going to have 1 over 2. Then this is just x to the power of 4. Then plus 1 over 1 is 1. So they're just going to cancel each other. Then we are going to have x to the power of 1. And then this is plus c. Yes, questions? Baba, you had a question? Or are you covered?
My point is that, can you please take me back to the mathematics where we make the first circle for the fraction? When we are supposed to cross multiply like it 2 to the power, 2x to the power of 3. If it's a multiply, you multiply denominator by denominator, numerator by numerator. But if it was plus sign there, 2 to the power, 2x to the power of 3, if it was plus sign, you was going to multiply, cross multiply.
No, you only cross multiply if you have a fraction equals to another fraction. We only cross multiply if you had 2x to the power of 3 equals to 1 over 2x to the power of 3. This is where you cross multiply. This will be over 1. This is where we cross multiply. Yes. So this way we cross multiply this one, this side. Please mute your mic.
Thank you so much.
Okay. Please mute your mic. Oh. Okay. Yeah. So this is where we cross multiply if we had an equal sign. So here we don't cross multiply. It's numerator times numerator, denominator times denominator. Someone else might just cancel these 2 and the answer will still be 1. So it's the same thing. All right. Yo, please mute your mic. Said. Okay. All right. Okay, Similani?
Yes, I just wanted to understand when you say, just go back to number C, where it
C,
says
yes.
2x to the power 3. Actually, I can just say 2x to the power 4 plus 1. So that one, which is a constant, in a case whereby it was a 2 or maybe 3, a different number, how will we introduce the x?
I don't understand what you're saying now. Oh, you're saying
What?
if this was 4.
Yes.
Yeah, it's the same concept. If this was 4, it was gonna be 4x to the power of 0 plus 1.
Or we just multiply the x with the
Yeah,
constant.
yeah.
Okay.
So it means that every time you integrate a constant, it's gonna be that constant with an x. So there's no need to
Okay.
go through all these steps. You know that if it's
Okay.
1, it's gonna be 1x. If it's 5, it's 5x. If it's 6, it's 6x. Every constant, when you integrate, it becomes that constant with an x.
Okay. And then with regard to what the other student has just asked now regarding the cross multiplication, in a case whereby maybe we're having 2x to the power 3 divided by 1 over 2x to the power 3, isn't it where we will introduce multiplication? Is it the same as cross multiplication or
No, I
multiplying by
said
the inverse?
you only cross multiply if you have an equal sign. We don't have equal signs here. You are multiplying a whole number with a fraction.
Actually, my question is, if we're having 2x to the power 3 divided by 1 over 2x to the power 3, in
Yeah,
order to
that
change
one
that
is
division, yes,
it's inverse, yes.
yes, that was my,
2x to the power of 3 over 1 over, ne? 2x
yes,
to the power of 3, yes. On this one, you will have, this will go to the top. So it's just gonna be 2x to the power of 3 times 2x to the power of 3 over 1.
okay, no, thank you.
Yeah, that's where they swap. We have, let me just do it like this. For people who, yes. So if you have something like this, remember this, it means you are dividing. So you're going to have 2x to the power of 3 divide. It's the same as, this is the same as this. 1 over 2x to the power of 3. And then here you change this to multiplication. That's where you cross multiply, I guess, yes. If you can put it that way. Yeah, then it becomes like this because we're changing a divide to a multiplication sign. That's where they swap. I guess you can
Okay,
cross
thank you.
multiply here. Yes, Kwaba, I think, yeah. Yeah, this is where you cross
Yes,
multiply.
that's another thing. Yes, ma'am, 100%.
Yes,
That's
yes,
another
when
thing
we
if you
divide.
can learn. Thank you.
Yes, all right. Okay.
Sorry, ma'am.
Yes.
One more time, like you said, most of the syllabus we've covered. So far, we are revising. How about somewhere, somehow, not always. You give us maybe one sample number D. You ask if there's any volunteer who want to give you all the steps, how must we do this one, so you can check how much we are understanding. Instead of always saying we asking you the question. Maybe one question, maybe any volunteer to do number D. If there's someone willing to take it, then they can volunteer themselves to it until you just correct it. That's why you make a mistake. Then that will be much more efficient to learn more faster. And also, it's like a revision indeed for everyone.
Oh, okay. All right. So any volunteer who wants to help me to do D? On that note, how do we integrate D? Any volunteer, you can unmute yourself because I can't see anything. You can, yeah, any volunteer?
Sorry, ma'am. Sorry, before we move to question D, just quickly at the top there by C still. I saw that you said 2 over 4 equals to 1 over 2. So for example, if it was like 4 over 4 or 3 over 4, would it still be?
4
Yeah.
over 4 is 1. You use your calculator. It's
Oh,
1.
okay.
Yes, we divide.
We
You can
divide.
use your
Okay.
calculator. We are simplifying it. Yes, we are simplifying it further. You can use your calculator.
Oh, okay. Okay,
Yes,
ma'am.
because you see 3 over 4 is like 3 divided by 4. 3 cannot go into 4. It leaves the remainder. So it's either that number is going to be a decimal number or it's just going to give you the same fraction.
Okay.
Yeah.
Okay, ma'am. No, that's noted.
Okay. All right. D. Who wants to do it with me?
X plus 2 equal U.
Okay. So we let 4x plus 2. Okay. So u is equals to 4x plus 2. Okay.
And then I'll say du over dx
What's that? Okay, du. Sorry. Yeah.
over
Yeah. Du over
dx.
dx.
Okay, so basically what I'm doing now is I'm trying to differentiate the 4x plus 2, right?
Okay.
So when I differentiate this, I know that it's going to be x, right, to the power 1 minus 1. That's going to give me 0, right?
Okay.
And then we know that x to the power 0 is equal to 1.
Okay.
Right? So we're going to say 4 times 1, which is just going to give me a 4. And then we know that the derivative of a constant is 0. So
Okay.
it's just going to be the 4. Right?
All right.
And
Yeah, okay,
then,
so just hold it. Let me just try to meet this person. Can I meet everyone? Then you'll unmute yourself, ne?
okay.
Yes.
Because it's so disturbing. For organizers, please help me to mute. Yes, you can unmute yourself now. You can continue.
And then I'm going to try to make dx the subject of the formula.
Okay.
So I think in the video you said we should swap. So it's going to be du. It's going to be,
Okay.
it can be du over 4
Okay. Du over 4
is equal to
mhm,
dx.
dx. So here we swap, ne?
Yes.
Okay.
And then,
Okay, just a minute. We'll just
okay.
show. Yeah, I'm swapping these two. So that everyone can see. Okay, yes, we can continue.
Okay. And then I'm going to write my formula again, my integrate, that formula of the integrate.
Okay, so what am I gonna write? We are
The
integrating again.
yes.
Okay.
dx.
Okay.
Yes, like that. And then we're gonna rewrite this formula, right? But then instead of saying 4x plus 2, we're gonna put u.
Okay. We have u. So it's 3 power of 6, ne?
Yes, ma'am. And then
Okay.
in the place of dx, we're gonna put du over 4.
Okay. Du over 4. Okay.
And then here I'm seeing 4 u to the power 6, right? So I think we're gonna have to put it at the on top.
Okay. This one, the u, what are you gonna do?
Or we
This-
can say the 4. I'm not sure which one is correct, but I know that the du over 4 has to go to the I don't know how to explain it, but before the sign.
Okay, so we're gonna
Saying
have
that
4.
4 over 4.
Yes.
Yes, and then we're gonna have
And then
1 over u to the power 6.
okay.
Like that, yes.
Yes.
And then I will we know that 4 over 4 is 1, right? But then I'm gonna
Mhm.
take my sign, the sign that I have, and then I want to put it on top. Oh, I can still change it into in ln x.
Okay. Remember ln x is when you have 1 over x. Ne?
1 over x. Okay, ma'am.
Yes. So if it
Okay.
has an exponent like this, we can say it's ln x. Yes. It's
Okay.
only when it's ln x. 1 over x squared, like 1 over x squared is not ln x, cannot be equals to ln x squared.
Okay.
Yes.
Okay,
The reason why we have a ln x is because the 1 over x, it gives us an error, or it's undefined. We can't define it. This is
Okay, ma'am.
undefined. Yes.
Okay, ma'am. So we're gonna say u to the power -6. We're gonna change this 1 over u to the power
Okay.
6.
All right. So this is just 1, right? So we
Yeah.
have u to the power of -6
Oh,
and
yeah.
du. Okay.
Yes. And then we're gonna take out the sign now because I'm gonna add my plus c. So I'm
Okay,
gonna
you're
say
integrating now, ne?
yeah, I'm integrating now. Yes, ma'am. Integrating now.
Okay. So we're gonna have
I'm gonna use the pluses as well if that's fine. We're gonna say
it's fine.
u. Okay, we're gonna say u -6 plus 1
Okay, to the power of -6 plus 1.
over -6 plus 1
-6 plus 1.
plus c.
Okay, plus c. All right.
Yes, ma'am. And then we're gonna solve this. Then we're gonna get u over to the exponent -5.
Okay. And we're gonna have u exponent -5.
Yes, over -5 plus c. And then we're gonna have to the u, we're gonna have to write it in its original form.
Okay. So u to the power of -5 is the same as, I'm just writing this here, ne?
Okay.
U to the power of 5. Okay.
Oh, okay, okay.
Yeah. So you said I must change this into its original form, ne?
Yes, ma'am.
So we'll have, we said u is 4x plus 2. Okay. So it's 4x plus 2, then to the power of -5, ne?
Yes.
Okay. Then over
-5.
okay, plus c.
Okay, so should we change the top part to
Yes.
what you said? Okay.
Yeah, so we make it positive. It must be in a positive form. So this will be, to make it positive, you just take it down. So it means it's going to be 1 over. So this negative, it doesn't matter. You can put the negative here. Whether it's at the bottom or next to it, it doesn't really matter.
Okay.
Yeah, so this is 5. And then yes, it's 4x
plus 2
to the power of positive 5. It's not
Okay.
negative anymore. Yeah. All right. Yeah, this is working. Great.
plus c.
Yeah. Thank you. Yeah,
Okay,
this
ma'am.
makes sense. Yes. All right. I saw a hand up. There was a hand up.
Hello, ma'am.
Yes, I saw a hand up.
Yes. I don't know, guys. Now I think Usisia, she explained well, but I think our methods are different because you've got your own way of finding it. So if now we are mixing things, I think this is for our revision on as individuals, guys. I don't know. Because Mina, we got lost. It's more like Umem was trying to explain Osisi, the two of them trying to figure it out. Then we get lost. I don't know. Then that way we get lost. So I think if it's one person explaining, then we do our own revision. I don't know. What do you suggest, guys? Because this thing of one person now explaining, we are getting lost.
Okay.
Can ma'am just explain to us? Then if we don't understand, we ask questions, then we can revise on our own. That's why we've got our spare time to study. I don't know.
Okay.
Yes, ma'am.
All right. Okay, yeah, let me continue explaining then. It's okay. It's fine. It's okay. And then, yeah. All right. Baba, you had what they said, no?
Yes, no problem. You can
Okay.
carry on. Thank you.
Okay. Let me just write here in case people. So here I substituted subs. D. What is it? I substituted U. Yeah, let me not write it here. I think I wrote it on my notes. Okay. All right. So now let's move on to C. So here we have to use the inverse of chain rule. So we have to use the U because this is a function. It's a composite function. All right. There's an exponent there. So we use the let U. Okay. If we didn't have an exponent, we're not going to use the let U. I will show you how we do it. So here we are going to use the let U. Okay. And then now we move on to, yeah, you'll see when I move on here. And then now let's move on to E. So E again, this is a composite function. We have 2x plus 1 to the power of 10. We cannot simplify 2x
Ma'am?
plus 1 to the power of 10.
Ma'am,
Yes.
can I ask a question before you continue with the question? I wanted
Are
to
you on
ask
D?
yes, on D
Okay.
before you.
Yes.
Basically, do you see the D? Because in D we use integration of substitutions, right? And you were like, we use it when we have only an exponent to a fraction, right? Is that what you're saying? We don't use the integration of the power rule.
We are still using the integration of the power rule here. This is it. This.
Yeah.
Yeah,
Yeah,
this is an
yeah.
integration of the power rule. So the
So-
reason why we're using, okay, you can continue. Yeah,
So
continue.
basically, we only use this formula. What I want to understand is that we basically use this formula when we only have an exponent and a fraction,
No,
right? Okay.
no. When we have an exponent, a bigger exponent,
Okay, like 6.
like 6, you'd even 2, because if I have,
Yeah.
even 2. If I have,
Mm-hmm.
even 2. Yes, even 2. Yeah, from 2 to
Mm-hmm.
infinity. Yes, let's say 2 to infinity. Because with
okay.
1, yes,
Yeah.
with 1, I have to use the ln. If
Okay.
it's a fraction with 1. If I
Mhm.
said to you integrate, let's say this was 4 over, let's say x, you still
Okay.
use the ln x here. You are going to say this will be, you're going to take the 4 this side, so this will
Mhm.
be 1 over x,
Mm-hmm.
right? And then this will be ln, it's going to be 4 ln x.
Okay.
Yes. So
Okay.
if your exponent is higher,
Mm-hmm.
yes.
Oh, okay. I wanted to understand that because I thought maybe there's a contradiction where we have to use the substitution when
Oh.
we use this. So I'm seeing you changing. That's why I don't understand why we're using this step when we at the beginning we were using the first integration of the power rule. That's why I asked.
Oh, okay. No, if we can check, we start with the substitution first and then we still use the power rule. This is the power rule because this is u to the power of -6 with respect to u. So this is the same as x to the power of -6. So if I said to you integrate this, what are you going to say? You're going to say this is x to the power of -6 plus 1, right? Then over -6 plus 1, then you say plus c, right?
Yes, ma'am, I understand you.
Yes,
Thank
you
you.
see, yes,
Thank you
we
so
still
much.
use we still use the power rule. It's just that we can't use the power rule if we have this binomial, 6 bracket. This means it's 6 brackets. It's gonna take us long to finish the sum.
Yeah, it's gonna be a long formula.
Ye-
So yeah. Okay,
yes.
thank you, ma'am.
All right. Okay, now we can move on to E. So if we can check, also E has exponent 10. So it means also we have to use that substitution method. We can't expand this. We can't make it 10 brackets. It's going to take us the whole day. So we are going to do the let u again. So we are going to let u. So this equals to, what did I say here? Okay, u equals to. So we let u equals to 2x plus 1. And then we derive this, the derivative of u over with respect to x dx is going to be equals to 2. Because when you derive this, just to take you back, when we derive 2x plus 1, this is equals to 2x to the power of 1 minus 1. Not over. What is this? Okay, 1 times 1 minus 1. Okay, let me not do this. This will take me more time. Yeah. So the derivative of 2x is 2. The derivative of 1 is 0. Yeah. Let me not do this. This will take me the whole day. Yeah. Okay. So this will be 2. And then after this, now we have to make dx the subject of the formula. And then we swap. So I wanted you to swap so that we don't take long to solve this. So I am just going to swap these two. It's allowed in maths. It's like cross multiplying. So this will be du over 2. And then it's equals to dx because I want to have a dx. I'm going to use it when I integrate here. So now we are going to integrate. So here, let me write I swapped so that you remember. So here we swap. We swapped the here. We swap these two. So we are going to have to integrate. So the integral of 2x plus 1 to the power of 10 dx is equals to the integral. Then now we change 2x plus 1 to be u. So this will be u to the power of 10. And then now we also have to change. We have to remove the dx. We replace the dx with the u over the 2. So this will be du. This will be du over 2. This is just times. Then I'm just going to take this side. So this is du over 2. So this is a fraction. I am going to have 1 over 2. Not 2, but 1 over 2 because this 2 is a denominator. So I am going to have 1 over 2. Then this is the integral of u to the power of 10. Then this is du. Then now I can integrate. When you integrate a variable, it must also with respect to that the same variable. That's why we are doing this. That's why we are substituting. We are replacing the dx and the u. So this will just be 1 over 2. And then the derivative of u to the power of 10 is just going to be, let me say times here. You can use brackets if you want. And then this will be u to the power of 10 plus 1. And then over 10 plus 1, the very same 10 plus 1. And then we are going to have then the plus c. And then now I'm going to have 1 over 2. Then this is a times. The bracket means we multiply u to the power of 11 over 11. Then we multiply these. Then this plus c, sorry. 1 times u to the power of 11 is u to the power of 11. 2 times 11 is 22. Then this is plus c. I hope that is clear. When you multiply fractions, you multiply the numerator with the numerator, the denominator with the denominator. All right, then now we move on to, I hope that is clear. So these are the basics of integration. These are the basics for integration so that when we do the application, we can just use the same thing. Yes, Valerie, I see your hand is up.
Sorry, ma'am. So in terms of u to the power of 11, so our u is going to be 2x. Just go on top.
Yes.
Sorry for me.
Ooh, sorry. Yes, sorry. I didn't finish the sum.
Okay. No, it's
Yes,
fine.
thank you. Thank you. Yeah, thank you. I didn't finish the sum. Okay, so yeah. Let me have, so the space here. Just okay. Yeah, thank you, Valerie. Yes, then your final answer will be. So this one, you'll see that your exponent of u is positive, so there's no need to move anything anyway. So we are just going to have our u, we said it's 2x plus 1. So this will be 2x plus 1 to the power of 11. It didn't move anything. Then this is over 22, then plus c. Yes, thank you. Yeah, this is plus c. Yeah, that's where it ends because our u to the power of 11 is positive. If it was negative, we want to take it to the denominator. And then now we move on to evaluating now. So they're saying, so now these are your definite integrals. So this is from 1
sorry,
to
Ms.
2.
Before
Yes.
you move on to the second equation, just there
Okay.
at the top, if you can please provide me with a bit of clarity, right? Under what circumstances do we swap?
If we have a fraction and a fraction or a fraction and a whole number, let's say I wanted to solve for x, ne? Let's say I have, let's say a over, maybe over 2. And then I have it equals to, okay, let me not say this. Let me put it this way. Let's say 2 over a, and then I have it equals to 5. And I wanted to solve for a, ne? So here, when you solve for a, ne? I'm just making an example. You want a to be the subject of the formula, so you're going to swap. You simply swap. I'm swapping because I don't want to do the long steps to solve. Mathematically, this is correct. We can swap here. So I am going to have 2 over 5, then is equals to a, because I want to solve for a. All right, so I'm going to show you something now. This is 5. Just want to show you something. So this is 5, this is a. So here I'm solving for a, right? So now let's look at this one. When I have, when I have 2, not 2, a, ne? A over 2, and then this is equals to 5. And I want to solve for a. My a is already at the top. When it's at the top, I just cross multiply this to the other side. I am cross multiplying this to the other side. I can still do the same thing here, but I will have to divide again. If I cross multiply here, I'm going to have 2a, 2 is equals to 5a, and then I will have to divide by 5 both sides. So if I do it the longest way, I have 2 over a is equals to 5. I cross multiply this one this side. Then I'm going to have 2 is equals to 5a. And then after this, I need to divide both sides by 5 because I want a to be alone. So it's over 5 over 5. Then now what happens? I am going to have 2 over 5 is equals to a. Why? Because these two, they cancelled. So on this one, I am trying to jump this step here. When I swap here, I could have just easily swapped. So if I do it the longest way, this is what's going to happen. That's why I just swap. I'm jumping. I'm avoiding to have this. That mathematically, I'm supposed to say a times 5. And then after that, I divide both sides by 5 to get my a alone. So me swapping, I'm just jumping this step because these two things are the same anyway. And then if it's like this, then I'm going to cross multiply the 2 to that side because my a is already a numerator. So you only swap if what you want is at the bottom. I think that's what you want. That's the question that you asked me. You swap if what you want is if it's at the bottom, is a denominator of a fraction. So if it's the numerator of the fraction, there's no need to swap. I'm just going to cross multiply this one this side. And then I will have a is equals to 5 times 2. Then my a will be 10. So because my a here is at the bottom, I'm swapping. You only swap if what you want is at the bottom. I hope, yeah, I think that's what you're asking. You only swap if what you want is at the bottom. And then, okay. Yeah, so can we move on to the next one? Number, what is it? The one of definite integrals where we have a limit. So here when we evaluate, we first need to integrate and then we can evaluate. So when we do this one, we are going to find the integral of this one. Remember, when you integrate, I'm going to do, I don't want to do it the longest way. Let me do it on the side. So if I integrate, I'm just going to do it on the side. If I integrate 5x to the power of 4 plus x to the power of 6 with respect to x, I am going to have 5 to the power of 4 plus 1 over 4 plus 1, if you remember. And this will be plus x to the power of 6 plus 1 over 6 plus 1. And then this is supposed to be plus c. Then my answer is going to be 5 over, so the 5 to the power of x to the power of 5 over 5, because 4 plus 1 is 5. And then this is plus x to the power of 7. Then over 7, this is plus c. And then if you remember from the video, I said that when we do this one, please don't include the c, because at the end of the day, the c's, they cancel each other out. So I'm not going to include the c because they cancel each other out. And then if you want to understand more, you can go to you'll see from your study guide, they will show you that they actually cancel out because the other one will be on the minus sign. The other one will be on the plus sign. Sorry. So I'm going to integrate before I apply my limit. So when I integrate, this is the answer that I get. 5 divided by 5 is 1. So my final answer will be x to the power of 5 plus x to the power of 7 over 7 plus c. So please ignore the c. Ignore the c. Ignore c when you do this one. So we are going to ignore the c for now. So this will be, I did it there. I am going to have x to the power of 5, then plus x to the power of 7 over 7. If you want to know, this is how I got my answer. So I'm avoiding to do long steps. And then don't forget the limit. So this is from 1 until 2. Then now after this, we apply the limit. When we apply the limit, it's always the bigger one minus the smaller one. So this will be x to the power of 5. So my x, I'm going to substitute my x. Wherever I see x, I'm going to put 2. So let me try to use different colors so that you can see. So here, so it's from 1 to 2. So I am going to start with 2. So this will be x to the power of 2. Oh, sorry, I need a bigger bracket. Okay. So I'm going to use a square bracket. So this will be, my x is 2. So this will be 2 to the power of 5, then plus 2 to the power of 7 over 7. And then we minus. And then we move on to the 1. So this will be 1 to the power of 5 plus 1 to the power of 1 to the power of 7 is over 7. Over 7, sorry. And then now I can get my final answer. I hope that is clear. You integrate first, and after you integrate, you apply the limit. So this will be the bigger minus the smaller. Can someone please assist with the answer here? 2 to the power of 5 plus 2 to the power of 7 over 7. Somebody?
We are
The
checking.
answer is 50,29.
It's what?
50,29.
50,29, then minus
1.14.
1.14. And then our final
The
answer will
final
be
answer is 49.15.
49.15. Okay.
Yes.
Yes. So this is how we evaluate. So that's our final answer. So remember, your assessment is a multiple choice. So it means you must find the answer that is more like the same as this one. So that's how we do this one. And then now we move on to B. I'm going to do it again. If you
Elma.
didn't get it, I'll do it again.
Elma.
So we are going to start by integrating. So we are going to integrate. So the integral of 6x squared plus 2x minus 1 dx, the answer will be 6x to the power of 3 over 3, then plus 2x to the power of 2 over 2, then minus 1x. If you remember, then this is plus c. I said please ignore the c. And then when you divide this, this will be 2 x to the power of 3, then plus 2 divided by 2 is 1. So it's just going to be x squared, then minus x, then plus c. So that's what we get when we integrate here. So remember that these are the same, these 3, and these 3, these 2, and these 2. And then if it's a constant, we introduce the x. Please don't forget that. And then now I'm going to have, I don't have a space, so I'm just going to write my equal sign here. So this will be the bracket. When we integrate this, we are going to have 2x to the power of 3, 2x to the power of 3, sorry, 2x to the power of 3, and then plus x to the power of 2, then minus 1. Or let me write it as a fraction first so that people can actually get it. So I'm going to write it as a fraction first. So I am going to have, this will be 6x to the power of 3 over 3, then plus 2x to the power of 2, then over 2, and then minus 1x. Remember I said please ignore the c. And then this will be with the limit. The limit is 3 and negative 1. And then I am going to have, divide this, it's 2x to the power of 3, then plus x to the power of 2, then minus x with the limit. Then now I'm going to apply this limit. I am going to have, okay, let me use different colors again. Okay. This is negative 1. So I'm just going to do this first. So I will have, red. So this will be 2, then times 3 to the power of 3, then plus, open bracket 3 to the power of 2, then minus, open bracket 3, and then here, the square bracket. I'm going to use a square bracket, yeah, okay. So this is going to be minus, then now we go to the green one, using the negative 1. So it's going to be 2 times negative 1 to the power of 3. Negative 1 to the power of 3 plus negative 1 to the power of 2, then minus negative 1. Can you please help me with the first answer?
It's 60.
It's 60. Then minus the second one.
0.
Minus 0.
It's 0.
0. Yes.
Okay, so the answer is 60.
60.
Yes. So that's how we do this one. Integrate first, and then the rest will follow. So I'm just doing this on the side so that we understand. Remember, I said we ignore the C because at the end of the day, the C this side will cancel the C this side. Because this will be negative C, then plus C is going to give us a 0. So we don't include the C. And then now let's move on to C. So question C, we have the integral of this, okay? So you'll see here, I wrote on the side, I said the integral of 10 over x, it's 10, then ln x plus c. As I said before, I can't use the substitution here because I don't have an exponent, so there's no, is there a need? There is a need here, no?
No,
No, there's no need. Yes, there's no need. Yeah.
there's no need.
Yes, there's no need. So I'm going to integrate because it's the, yeah, there's no need. Thank you. So I'm going to integrate here. So I will have the integral first of 10 over 6 plus x dx is going to be equals to, this is 10, ln bracket 6 plus x, then plus c. I'm applying what I wrote here at the top. So it means I am going to have here the integral, my answer, I got 10 ln bracket 6 plus x. Let me just use square brackets because I have a smaller bracket. And then with the limit of 9 and 5. So it's from 5 to 9. And then now we can apply the limit. So when we apply the limit, we're going to start with the red one. The red limit. So I am going to have, okay, square bracket, sorry. I will have 10 ln, and then I say 6 plus 9. And then this will be minus the green one. It's going to be 10 ln, sorry, 10 ln. Then it's 6 plus 5. And then, yeah, that's it. Someone please assist with the calculator. There's a lien on your calculator. Please use it.
The answer is 27,08.
27,08. Okay, yeah, 0811. It's fine, 0802, because 1 is smaller, so it's just going to be 08. And then minus
23,98.
23,98. And then now let's minus the 2.
The answer is 3,1.
Okay, 3,1. 3,1. Okay. All right. There were no two numbers there. Oh, yeah. Oh, 0 and 1. Okay. Yeah. 3,1. Okay. Yeah. So that's how we do it. And then, yeah. And then we move on to, let's look at this application. I didn't take all the questions. I'm just doing a few so that when you do your assignment, it can be a bit easy. All right. So they're saying in economics, many functions are expressed in marginal terms, rate of change, and then integration helps recover the total. So note that the rate at which a function changes is given by the derivative. So every time they mention the rate of something, it means you need to derive that function. Please note that. And then they're saying, let's do, okay, total revenue from marginal revenue. So if you remember from our derivatives, when we wanted the total revenue, we would derive the marginal revenue, and then it gave us the total revenue. So remember, integration is the reverse of the derivative. So now because we want the total revenue, it means we have to integrate the marginal revenue. So we are integrating with respect to Q because our function for total revenue has a Q. It's P is equals to, then there's a Q, letter Q there, hence this Q. Please note that this is the same as if it was X, it was going to be dx. And then, oh, why am I repeating the same thing? Okay. And then, I'm sorry. Okay. To delete, let me just cut. Okay. And then total cost from marginal cost, we also integrate the marginal cost. Why did I say revenue here? This is cost. And then this is cost, sorry for that. Okay. All right. And then we have an example here. So remember, I'm just doing examples so that you can understand. I didn't take all the examples, but then I just wanted you to understand your assignment again. So they're saying a small furniture manufacturer has a marginal cost function of this. It doesn't matter what your function looks like, but yeah. So it has a function of this where Q is equals to the number of table produced per day. And then the fixed costs are 500. So fixed cost, it means that my C is 500. Please note that. And then they're saying find the total cost. So we said that to find the total cost function, we have to integrate the marginal cost function. Okay, so we are going to integrate this. I think we now know how to integrate. So we are going to say my total cost is equals to the integral of my marginal cost, dq, so with respect to q. And then this will be, it means it's the integral of 40 plus 2q dq. All right. Then now we can just integrate. We all know how to integrate by now. You know that the integral of a constant is going to be that constant with the variable. So it means that the integral of 40 is going to be 40q. By now you know. And then this is plus 2, then q to the power of 1 plus 1. Remember, there's a 1 here. So there's a 1 here. So this is 1 plus 1 over 1 plus 1. And then we say plus c. And then this will be 40q, and then plus 2, then q to the power of 2. 1 plus 1 is 2. And then this is over the same 2. Please don't forget. And then plus c. And then we are going to have 40q, then plus 2 divided by 2 is 1. So they basically cancel. So we have q, then plus c. And then remember we said that our fixed cost is 500. So remember fixed cost is C, ne? Don't forget that. So we can just substitute our C, right? So we can substitute our C here. Hope I get that, okay. So this is equals to 40q, then plus q squared, and then plus C. So you can write it in order if you want. Your C is what? We said C is 500. C is 500. C is 500. So this will be 500. So you can rewrite this in the descending order. So it's up to you. You can say q squared plus 40q. No number is moving left and right. Ne? So you can't say other one is going to be negative. Please, the numbers are not moving left and right. I'm just moving them from here. There's no jumping in equal sign. Okay. All right. Yes, questions? Okay. All right. So I guess we're fine. I guess everyone is fine. So I just want to check if it's still recording. Okay, we're still recording. All right.
Sorry,
So
ma'am.
I guess we're fine. Yes.
Sorry, ma'am. Can you just please, yes, move up a bit? I just want to see the question and the explanation at the top there. Just the wording, not the sum, just the wording.
Okay. You mean this?
Yes, ma'am. Is it where it starts there by in economics, ne?
Yeah, just yeah.
Oh,
Just
okay,
yeah,
okay.
just yeah. Okay.
Guys,
Ma'am,
thank you.
Okay.
ma'am,
Yes.
can I ask,
Yes.
right? You see the answer
Mm-hmm.
when you said like you're finding the total cost function, right?
Mm-hmm.
So I see there because you're using Q as X, right?
Mm-hmm.
So the answer always has to be in a sign of a cubic function.
A
The way
cubic
you put
function.
it down there, you see?
Here.
Yeah.
Oh yeah, I just wrote it in a descending order. Isn't it in maths? It's always
Yeah.
ax squared plus
Yeah.
bx plus
From
yeah,
the
like your
biggest to the
exponents.
lowest. Yeah.
Yes, yes. I just wrote it that way.
So are you saying that every time when you try to find the total cost function, we use this rule where at the end it has to be a cubic function, ma'am?
No,
Or do
I'm
you?
just yeah, you
Yeah.
just check your answer on the multiple choice.
Mm-hmm.
I just did this because you know
Yeah.
in maths we writing it in order. So this is how you write it in order.
Oh,
But
okay.
these two are the same.
Okay. Thank you.
Yeah. Yeah. Okay. Now let's move on to okay. Okay. Now let's move on to consumer surplus. Sorry, our class started at 6, ne?
Yes.
Okay, sorry, I'm confused. This is confusing me, ne? This is confusing me, sorry. Okay. Okay, so consumer surplus means the benefit measures the benefit the consumers get when they pay less than what they are willing to pay. So we already did the notes part of this when we did consumer surplus and producer surplus, ne? So I'm just doing this example again, just so that you can do your assignment. So the formula for consumer surplus in this topic, it's this from 0 to Q0, and then demand function. So we integrate the demand function with respect to Q, and then we minus P0 times Q0. So you see this on your notes. If you want more explanation, it's there on your notes. Ne? So here we have an example. So the example says a smartphone retailer in Johannesburg sells devices in a competitive market. The demand function for a particular model is, so we have our demand function where P is the price in rand and Q is the number of phones demanded per week. And then they're saying that the demand market price is fixed at 8,000. Okay. And then they're saying calculate the consumer surplus. All right. So okay, so before we calculate, we need to find our Q. Yes, we need to solve for our Q and also we must have our P. All right, before we solve. Yeah. So we are going to start by solving for P and Q. So P is equals to this. Then we said that the market price is fixed at this. So it means our P is 8,000. So this will be our P because it's the price. And then now we have to look for the number of cell phones first. So we are going to have, because we have P is equals to 12,000, sorry, minus 50 Q. And then we said P is 8,000. So this will be 8,000 is equals to 12,000 minus 50Q. And then now we are going to start by finding Q first. So that's what you do. The first thing, that's what you do. Then we take this to the other side. So yeah, so we're gonna have 8,000. When you move 12,000 to your left, now it jumps an equal sign. It's gonna be a minus, né? When it jumps an equal sign, it becomes a minus. And this is equals to negative 50 Q. And then this minus this, what do we have? What is the answer? Is it 4,000?
Yes, minus 4,000.
4,000, yes.
Okay, negative 4,000. And then it's equals to negative 50 Q. Then now we need to solve for Q. So I'm going to rewrite this step so that when people check the notes, it's easy. And then now we divide both sides by negative 50 because we want Q to be alone. We are solving for Q. Divide by this. Again, I'm doing this because so that people can understand when they check the notes. Oh, sorry. And then we are going to have, what is negative 4,000 divided by
80.
negative 80?
Yes.
Okay, so it's 80 cell phones. Okay, so my Q is 80. All right. Okay. I can see my notes. Okay. And then now we have to calculate. So we have our Q, we have our P. So now we can calculate our consumer surplus. So consumer surplus. So second thing that you do, you're going to calculate the consumer surplus. Consumer surplus is equals to, we set the integral. This is Q0 from 0 to that, then the demand function. Demand function. And then with respect to Q, and then minus P0 times, yeah. P0 times Q0. Okay, so now we are going to have to substitute. We have everything that we want now. So your Q0 will be this 80. So this will be, these are the cell phone in a week, I think. So this will be the integral of 80 from 0 to 80. And then our demand function, this is our demand function, 12,000 minus 50, with respect to Q. So it's 12,000 minus 50Q, dq. And then this is minus P0 and Q0. So this is 80 times. Your P is 8,000. So this will be 80 times. It's 8,000 times 80 or 80. Yeah, that's what we made. Okay. And then now we can solve. Now we can integrate first. So when we integrate this with the limit, the integral of this, we know we're going to have, let me write it on the side, sorry. I'm just going to write it on the side. The integral of 12,000 minus 50Q. dq is going to be equals to, remember, if it's a constant, it will have a q. So this will be 12,000 q, then minus 50 q to the power of 2, because it's 1 plus 1, then over 2. All right, then plus c. Remember, we ignore the c every time we have a limit. And then this will be 12,000 Q, then minus 50 divided by 20 is 2, so it's 25. 50 divided by 2 is 25, so this is just 25Q. Then plus Q squared, then plus C. So that's what I'm going to do. So I'm doing it on the side so that I don't have a lot of steps. Can I finish, Paba? You'll ask when I'm done. So when I integrate this, I am going to have 12,000. Okay, let me write it in red. I integrated this part, so this will give me 12,000, then minus 25Q squared, 12,000 Q, and then minus 25q squared, and then not forgetting the limit, which is 80. And then let me put the 0 in green, then 0. And then this is minus. What is 8,000 times 80?
640,000.
640,000.
Yes.
600. Like this?
640.
640. Oh,
Yes.
like this.
640.
Oh, thank you.
Yes.
Dang, okay. Right. Baba, you wanted to ask here?
Yes, ma'am. For they on the integral. That divide by 2, 50 divided by 2. Where that 2 does it come from? Yes, that one. 50 minus 50 squared. I understand you multiply to get rid of the bracket. But that over 2, I'm a little bit lost. Yes.
No, which bracket are you getting rid of? You are integrating. What is the integral of 50q? When I say to integrate 50q, is it not? How do you integrate this?
You didn't multiply 50 multiply by 50q multiply by this q outside, and you get 50q squared. Yes.
This is the same as that. Remember, I said that here instead of x, we're writing q. This is the same.
Okay.
This is like one. So it's like 12,000. Sorry, this is like 12,000 minus 5x, and I say integrate this dx.
Okay.
Do you multiply 5x with dx when you integrate?
No.
No. You are integrating with respect to x. The dx means with respect to x.
Okay.
Yeah. So the only difference here between this one and this one is the letter x and the letter q.
Okay, thanks. I get the point.
You understand now?
And you can carry on.
Okay. All right. So now we are going to apply the limit. So when we apply the limit, we are going to have, I'm going to use a square bracket again here. So this will be, but it must be within, so it cannot disturb the other one. So this is just going to be 12,000. Let me use the red. Or the 80, so it's going to be 12,000 times 80, and then minus 25, then this is 80 squared. Okay, and then minus, and then we do the same for the green one. So this green one is 0, so everything is going to be 0 here. For the green one is going to be 0. 12,000 times 0 is 0, minus 0 is 0, so everything is 0 for the green one. So we are just going to have that. So I'm going to have minus 614,000. So can someone assist us with a calculator?
800,000.
800,000.
800,000. And then
minus 640. Then the final answer is 160,000.
Okay. Yeah, so this is how we do it for the consumer surplus. So every time for the green one, you get the 0 because 12,000 times 0 is 0, minus 25 times 0 to the power of 2, it's 0. This is going to give us 0. This will give us 0. That's why I just wrote the 0 for the green one. It's not going to, yeah, it's just going to be 0. All right. But it's not always 0, ne? It depends on the function. It depends on the function. So I only did it here because it's going to give me a 0. So let me just do it on the side so that you can remember. So 12,000 times 0 minus 25,000, 25, sorry, to the power of 0. My answer is going to be 0. That's why I wrote the 0. So that when you later you check it, you understand why I wrote 0. All right, now let's go to producer surplus. They're saying it's the benefit producers receive when they sell at the price higher than their minimum acceptable price. So that's the formula for the producer surplus from your study guide. So I'm just going to do this example so that you understand. This is my last example. Can understand. Okay. So they're saying, suppose the market has the supply function, this, and then the, what is it? Why is it saying supply? Supply function and the demand function. Why is it saying supply? It should be supply. Okay, let me just check my notes. Yeah, the other one is supply. Yeah, this one is demand. Minus is demand. Sorry. Let's just correct that. That is demand. Can't be supply. Okay. So the demand function is this one of a minus. So please remember that demand function is a minus, supply is a plus. All right. So the demand function and supply. So they're saying calculate the producer surplus. So we have to calculate our Q and our P. All right. So here we are not given either. So what we're going to do is you're going to equate these two. So remember when you have these two on your graph, they meet at some point. So we are going to solve this simultaneously. All right, so I'm just going to remind you, we start by equating. So step number 1, you have to solve for P and Q. So please equate these two. So you are going to say PD. I think we did this at some point, just that, yeah, it was at the beginning. So I'm just going to remind you. And then we equate now. So this is our PD. It's 86 minus Q. Okay, I'm sorry, capital letter Q and small letter q is the same thing, please. Squared, then is equals to 14 plus Q squared. And then now we solve like terms one side, apples with apples, bananas with bananas. So I'm just gonna take this one this side, that one that side. Okay, so I have, okay, let me just do this. 86, I'm gonna take the 14 this side. It's a positive, it's gonna be minus 14. And then this is equals to, then I have Q squared. Then I take this to the other side, it's going to be a plus Q squared. When they jump an equal sign, they change the sign. So we say 86 minus 14, what is the answer?
72.
72.
72. And then it's equals to these two. It's two of them, so it's twice. When you're adding this, it's like x plus x is 2x. So it's just gonna be Q to Q, 2Q squared. Let me just write it here. When we say x squared plus x squared, our answer is going to be 2x squared, is the two of them. If you are saying 2x squared plus 4x squared, you are going to have a 6. I'm just doing this for people who are struggling with maths. When you're adding, you add the like terms, right? And then we are solving for Q. We are going to have 72. I'm going to rewrite this so that it's easier to understand. So now I divide by 2 both sides because I want my Q. Then my answer is going to be, what is 72 divided by 2?
36.
36.
36.
Okay. All right. So 36. So because this is a Q squared, because of the square, we are going to have 2 solutions. You're going to have 2 answers for Q. I'm going to write it here on the side so that you understand. If I have x squared is equals to 4, and I want to solve for x, let me make it 16 so that it's easy. And I want to solve for x. My answer for x is going to be, I am going to take the square root both sides. So I'm going to have x squared is equals to 16. And then to remove a square, you must always take the square root. Please mute your mic. To remove a square, this square, you must always take the square root. So this will cancel the square. And then my answer will be x is equals to 2 answers. The square root of 16
Plus or
is
minus
4.
6.
Plus or minus 4. Plus or minus 4. So my x will either be equals to a 4, or my x will be equals to a -4. So there are 2 answers for 4. So because of here, you cannot have a negative quantity. You are going to reject the negative one. We are going to reject this one because you can't have a negative q. So we're just going to take the square root. You're going to take the positive one. So let's take the square root here. What is the square root of 36?
6.
6.
The square root of 36 is 6. We are taking the square root. We reject the negative answer. We take the positive one. So we're just going to have a positive 6. So my q, therefore, my q is equals to 6. I saw a hand up. We reject the negative one. We are going to reject this, please. Remember that we are rejecting this one. Okay, so our q is 6. So now we have our q. Now we can find the p. So our p is going to be, therefore, my p will be, if you remember last time I said that you choose any equation here to solve for p, the answer will be the same. So I'm going to choose the one of 14. It doesn't really matter. This will be plus, my q is a square, so this will be 6. I am using any equation. Please, it doesn't matter which one you use. Any equation, you will get the q. Please, what is the answer?
50.
15. Okay. So here we are applying our simultaneous. We're equating here. It's the same as simultaneous. And in step number 2, now we can apply the formula. So our producer surplus is equals to, I guess it's the opposite of that one. Yes, it's P0, yeah. So this will be P0 times Q0. And then we minus the integral of the supply function. That one was a demand. So now this one is a supply function. What am I writing? Okay, here. This is a supply function. So we are going to use the supply function with respect to Q, okay? And then now we can start. Okay, so I have to add another page. What is this? Okay, sorry. Insert. Where can I insert? Okay, so I'm going to insert a blank page. I hope it doesn't move my things. Okay, it did. I'm going to move my cursor here. Jeez. Okay, what am I gonna do here? Okay. Okay, yeah. All right. So I am going to now substitute, but I need to integrate on the side. So remember, that's what I did the last time. I integrated on the side. Okay, so let's substitute first. So our P0, it's 50, and then times our Q is 6. And then this is minus the integral of our supply function. We have not the supply, not the demand. We have, okay, this one, 14 plus Q squared, okay? So this will be 14 plus Q squared. And then this is with respect to the Q. Then this is equals to, so now let's integrate on the side so that we understand again. So when we integrate 14 plus q squared, the q, I didn't write the limit. Did I write the limit? No. So this is q, so it's 6. And then the 0, this is q0. Q0 and 0. And then this is 6. And then I'm going to use the green one for 0. And then now we are going to integrate so that we just substitute. I'm just doing this with respect to q. When you integrate this, if it's a constant, it's just going to be 14q. And then this is plus q to the power of 2 plus 1. It's 3 over 3. Let me use the black one so that you understand where I got the 3. So this is 3 and then over 3. And then remember this is plus c, but we are going to ignore the c. I repeat, please ignore the c because it's going to give you a 0 when you do the limit anyway. They're going to cancel out. So what is 50 times 6?
100.
Huh?
300.
300, thank you. And then minus, and then now the integral, I'm going to start with the red one. Oh, no, actually. The answer for the integral is 14q. And then this is plus q to the power of 3 over 3, because it's 2 plus 1 over 2 plus 1, which is 3 and 3. Ne? And then I said, please ignore the c. So we're just going to have, and then now our limit is 6. And then I'm just going to use this and say this is 0. And then now we can solve. This is 300, then minus. Okay. Now we are minusing. Okay. So this will be, I'm going to start with the red again. So it's going to be 14 times 6, then plus 6 to the power of 3 over 3. Okay. And then this is minus. So when you minus, we are going to have, so here's not going to give us a 0. Minus the green one, we are going to have 14. Actually, it's going to give us a 0. Oh, it's a 0. This is just a 0. It's going to give us a 0 because 14 times 0 is 0. 0 over 3 is 0. It's not undefined.
You wrote 16 instead of 6.
I wrote
16 divided by 3.
no, it's a bracket. Sorry, it's my bracket. You don't see my bracket. It's a bracket. Excuse. Okay, yeah, this is a bracket. Sorry, it's a bracket. And then this is 0. All right, someone help us with the calculator.
It's 156.
It's going to be 300 minus 156.
Okay, then the final answer.
And the answer is 144.
144. Yeah, that's it. That is it. So that's how we do it. Step number 1, find your P and Q, make sure that they're there. Step number 2, just substitute, integrate this part, apply the limit, then that's it. And then you get your answer.
Sorry, ma'am.
Yeah. Yes.
Can you just go up a bit? I just want to see the question.
Oh, the question. Okay.
Again. You see on the limit it's 0 to 90. Then how did you get to have 6?
It's not 90. This is the formula. It's Q0 from your study guide.
Oh, I thought it's 90. I'm sorry.
Oh, yeah, it's not 90. It's Q0. It's a study guide. That's the Q. It's here.
Sorry, ma'am.
Yes.
Please don't forget to attach the Excel, I mean the word where you're working, because on the class of the 6th, you forgot to attach. We only have the last attachment on the 3rd.
Oh, okay. That one, I don't have the attachment. Unfortunately, I don't have it. I was not the one teaching, so I don't have it. And yeah. Yeah, I don't have.
No problem.
Yeah. So that's why I had this class, just to make sure that we are fine.
Sorry, ma'am.
Because if you can check, we are done. Yes. Can I just stop the recording so that it's not long, Anne? Because I think, yeah, it's gonna be too long. Okay, yeah, you can ask.
Ma'am, there is a question you